Hello amigos, this question is based on concept of nature of roots of quadratic equation. The quadratic equation he has given is x square plus 4x minus n is equal to 0. He is saying that both the roots of the equation should be integers. How many values of n I can put from n belongs to 20 to 100. Basically, he is saying that you can take n values from 20 to 100, but what you should understand is both the roots must be integer roots. Accordingly, take the n values and tell me how many such n values you can take such that both the roots of the quadratic equations must be integer roots. Let us try to understand the roots of the quadratic equation. Roots of the quadratic equation are minus b plus or minus square root of b square minus 4ac by 2a. So that would be x is equal to minus 4 plus or minus square root of b square. B square is 4, 4 whole square minus 4, a is 1, c is minus n by 2a. 2a is nothing but 2 into 1. So that would be x is equal to minus 4 plus or minus square root of 4 square is 16, 16 plus 4n by 2. That would be, now I can take 4 from 16 and 4n, so that is minus 4 plus or minus square root of, if you take 4 common, 4 plus n divided by how much? 2, which would be minus 4 plus or minus root 4 is 2, so 2 into square root of 4 plus n by 2. Take out 2 as a common and cancel the 2, so that would be minus 2 plus or minus square root of 4 plus n. What I understood finally is one of the root of the quadratic equation is minus 2 plus square root of 4 plus n, and second root of the quadratic equation is minus 2 minus square root of 4 plus n. So I can clearly see that to have minus 2 plus square root of 4 plus n as an integer root, minus 2 is an integer. So if square root of 4 plus n also is an integer, then total integer plus integer is an integer. My target is done. Minus 2 is an integer. If square root of 4 plus n is also an integer, then integer minus integer is also integer. So what I understood is, if square root of 4 plus n is also an integer, then I can say that minus 2 plus square root of 4 plus n also will be an integer, because integer plus integer. Also second root minus 2 minus square root of 4 plus n also will be an integer, because integer minus integer. Ultimately what I understood is square root of 4 plus n should be an integer. But let us understand how can square root of something can be an integer. Now let's say square root of dabba should be an integer. Let's understand. Let us say I have square root of 2. That would be approximately 1.414, not an integer. Let's say square root of 3. That would be 1.732, not an integer. But what about square root of 4? It is 2. Yes, it is a perfect integer. So will you get square root of 5 as an integer? No. Root 6? No. Root 7? No. Again, where will you get the integer? Square root of 9, which is 3. Yes, it is an integer. So what I understood is, why square root of 4 is an integer? Whatever is in the box, that is 4, is a 2 square, perfect square. Why square root of 9? 3 is an integer, because whatever in the square root, that is 9, is 3 square, which is a perfect square. So what I understood is, if square root of dabba is an integer, then what I understood is dabba should be perfect square. That's what my understanding is. If square root of dabba, in the dabba 4 plus n is there, is an integer, then dabba has to be perfect square. In the dabba what is there? 4 plus n, which should be a perfect square. And also understand that n should be taken from only 20 to 100, not anything. So let us understand, from 20 to 100 I should take the n, and I should count how many such perfect squares can come. Okay, let us start with the least value, that is n is equal to 20. If I put n is equal to 20, what is the value of 4 plus n? That is 4 plus 20, which is 24. Is it a 24? Is it a perfect square? No, not at all. 24 is not a perfect square. What if you put n is equal to 21? If you put n is equal to 21, 4 plus n would be 4 plus 21, which is how much? 25. Is it a perfect square? Yes. If you put n is equal to 22, so which would be 4 plus 22, which is 26, not a perfect square. So, sir, should I count everything like this? Time will be wasted. Yes, of course. But don't go like this. Instead, what you can do is, you have substituted the least value possible 20. Now, up to, let us suppose you have substituted the highest value possible, that is n is equal to 100. Put n is equal to 100 here. So, if you put n is equal to 100, so 4 plus n value will be 4 plus 100. So, that would be 104. This is not a perfect square. This is not a perfect square. But before that, a perfect square will come, that is 100. So, if this has to be 100, so 4 plus 96 will give 100, which means that n has to be 96. I can see that maximum perfect square you will get is 100, which is 10 square, and minimum perfect square you will get is 25, which is 5 square. In between them, you will also have 6 square, 7 square, 8 square, 9 square, up to 10 square. Perfect square you are getting from 5 square to 10 square. If you count all the values from 5 square to 10 square, how many values will be there? They are not total 5. They are actually 6. Don't get confused and pick the wrong option, because including 5 square, total number of values will be 6. If you go on putting n is equal to 20 and some other n up to n is equal to 96, if you pick such n's as a 6 number of n's can produce perfect squares. Total 6 such n values you can pick. So the answer is option A, which is 6 n values.